All right. So at this first topic that we're going to cover, so we have lots of ideas, and we'll reach out to some of you and ask for ideas about some of the tips and tricks, the things that you'd like to hear about. But for this first one, we're starting with something that we think everybody should know about. Many of you probably have seen this or come across this already, but we think everybody should know about this. So we're going to start with the current limiter and velocity limiter in Particleworks. And so this is an extremely important thing that I think everybody should be making full use of. And we'll jump right into it. And so the current limiter and the velocity limiter are meant to address a specific problem. And that's that for various reasons, instabilities can be generated in your model, which accelerates particles to unrealistic velocities. So I created a little model here in which I intentionally introduced an instability. So the way that I did that is I actually instantly moved this little block on the bottom right there into the fluid. And so this is a solid, and when it instantly moves into the fluid, there's overlap between that block and the fluid. In this case, it's water. And both of those things can't exist in the same space at the same time, so it creates this instability and suddenly shoots off all of these particles at high velocities. And so this is something you may have seen in different ways in your models. Instabilities can be created in multiple different ways. A lot of times it is because there's solid geometry and fluid particles that are trying to exist in the same space at the same time. But there's multiple ways that it can happen. And so this is just a simple model. We have a little inflow at the top here that shoots a little stream into this little bucket here. Nothing too complicated, but we want to see some of the things that can happen even though I'm intentionally introducing this instability. What are some of the things that we can do once we apply the current limiter or the velocity limiter? And one of the things that you'll notice in your simulations, or what will happen if you come across this problem, is if you don't have the current limiter or velocity limiter on, you'll see suddenly your time step is going to start dropping drastically. So in this simulation, I started off with the time step of 1 times 10 to the negative fourth, 1e negative 4. And then immediately, as soon as I introduce this instability, it drops to 1e negative 6. And sometimes it can be even more drastic, and you can come across an error in which it'll say something like you need to decrease the initial time step. And Particleworks is recognizing that it needs to drop the time step, but it needs to drop the time step so much that it thinks something went wrong. So at a certain point, it'll just come across an error. And in this case, the simulation continued, but it did drop the time step quite a bit. And obviously, this is just bad data and just incorrect. And so we can solve this by using the current limiter. And the current limiter is found in these advanced settings. In the Particleworks GUI at the top right, there's a little gear. And when you press this gear, you'll come across some simulation options, and one of these is the current limiter. So the current limiter limits the velocity of the fluid in order to keep the time step constant. And this is incredibly valuable because before we had this instability, and it was causing these drastic problems. But once we introduced the current limiter, it localized that instability much more so that the simulation as a whole is still useful. Now, it still may be worth going into and figuring out what's causing this instability, but a lot of times this is actually especially for this case, the current limiters solve the problem enough to where the results are likely just good for this simulation. Now the velocity limiter is another option right next to the current limiter in that same section of Particleworks. And so the velocity limiter does the same thing, but instead of limiting it using a current number, it does it using the more direct method of actually limiting using the velocity. So in this case, I limited the velocity to 1 meter per second, and you see something very similar happen. In both cases, we're getting very similar results, and in both cases, we're able to successfully limit that instability and localize it much more than we saw previously. So that's good, but you do have to keep in mind that when you're using the current limiter, you are forcefully reducing the velocity, and there is the potential to lose kinetic energy when you're using the current limiter or the velocity limiter. And I'll show that in this case. In this case, I wasn't as careful with setting my initial time step, and when I did that, it limited the velocity to a much lower number. And in this case, I'm down to 0.4 meters per second. And hopefully you can tell just by looking at that something just looks off about it, and particles are no longer able to accelerate as they're being pulled down by gravity. And there's just quite a bit that's just incorrect in the physics about this. So you do want to make sure that when you're using the current limiter or the velocity limiter, you are limiting it to the actual physics of the system. You don't want to cut off velocity that is actually produced by your system. So I've talked about the velocity limiter and the current limiter. Both of them do pretty similar things, but there is a subtle but important difference between them. The current limiter will actually keep the time step constant, while the velocity limiter still allows the time step to change. Now there's reasons why you might want to use both of these. If you're a little bit more unsure about what the velocities are in your system, you may want to give it that freedom to change the time step. But in most cases, and especially when I'm using the explicit pressure model, from what I've found, I like to use the current limiter. And the reason for that is that, especially with the explicit pressure model, the simulations tend to be a little bit more stable when using a constant time step. There are some exceptions to that, and both of these do pretty similar things, but that's just something to keep in mind that I'd say in most cases I end up using the current limiter at the moment, but the velocity limiter is also quite powerful, and I use it quite frequently when I'm using an implicit pressure model.